So in the previous video, we talked about the mathematical relationship Boyle's law between a gas's pressure and volume. Charles' law also deals with volume, but it speaks to volume and temperature for a gas sample. So what Charles' law states is that the volume of a gas sample increases proportionately or linearly with temperature, assuming that the number of moles of gas and the pressure are constant. So for example, let's say I have this balloon and some cold ice water. If I increase the temperature that those gas molecules encounter, if I increase their temperature, the volume of that gas will expand due to the extra motion that those gas molecules have. So as volume increases, temperature increases. That is Charles' law. And just like we were able to previously with Boyle's law, we can make a mathematical expression with regards to volume and temperature. If we were to say we had an initial volume and an initial temperature, we could find a final volume and a final temperature from this expression. Specifically, V1 over T1 is equal to V2 over T2. So that is the mathematical expression you will use for Charles' law. The other important point to know or to remember about Charles' law is that when you do calculations using it, you must always use temperatures that are in the scale of Kelvin. And that's because Kelvin is based on a scale of absolute molecular motion being still at 0. And so since it's based upon absolute 0, you will never have a temperature, at least in the problems that we do, you're never going to have a temperature that has 0 to it. If you did have one of these values being 0, then obviously you would get a volume that doesn't make sense. Anything divided by 0 is infinity. So you must use your temperature in the Kelvin scale when doing Charles' law problems. And we're going to do an example on the next slide. Speaking of cooling balloons, let's say that we are cooling a balloon from room temperature to the temperature of liquid nitrogen. And let's say the volume of the balloon initially is 2.7 liters. What is its volume after it cools? So we have two temperatures. We have an initial volume. We need to find a final volume. So we're going to use Charles's law. We're going to make sure that our temperatures, both of them need to be in Kelvin. So our second temperature for liquid nitrogen, our T2, is already given in Kelvin. So that was nice. We can go ahead and convert our initial temperature, our room temperature in Celsius to Kelvin, by adding 273. So I now have a T1 that's in Kelvin. My T2 is in Kelvin. I have an initial volume of 2.7 liters. I am looking for my final volume, my V2. And so this is the mathematical expression that I need to solve for V2. So what I recommend doing is to get V2 by itself, because that's the variable that we're solving for. I would cross multiply so I can get those variables out of the denominator. So when doing that, when cross multiplying, I get V1 times T2 is equal to V2 times T1. Then I need to get V2 by itself, so I'm going to divide both sides by T1. And doing that, my T1 cancels, and I get my V2 equaling V1 times T2 divided by T1, which is more neatly written down here. And now I'm at a place where I can start plugging in my given information to solve for the variable I am interested in. And again, I really recommend when you put in your given information, Make sure to include the units so you can clearly see the units cancel. So my Kelvin units cancel. I'm left with liters. That's what I'm looking for. I'm looking for a volume of V2 in liters. So doing the appropriate multiplication and division, you should get 0.70 liters. And that makes sense. You would expect a volume that is smaller than what you started with because your temperature decreased. So that is how you do problems with regards to Charles' law.